All right, guys. So
Hey guys.
we're here at 11.5.
Yep.
11.4 was the length of,
A part of the an arc.
yeah, so kind of the
Part
piece
of
of
the
the circumference, yeah.
Yeah.
And so now we're going to look at, if you look at the drawings here, you can see that little blue piece in the circle. Now we're looking for like a piece of pie out of a circle.
And what we're going to start with is the full circle.
Yeah.
And then kind of the same thing. You
Yeah.
just need to figure out what part of the circle you have for that piece of pie, and so what's the area. It's just a part of the circle. It's a fraction of the circle. You just
Yeah.
have to figure out how much of the circle you have. So
Yep. And so the formula we use for area of a circle is pi r squared, okay, or pi times the radius squared. And like the big thing you got to remember here, guys, is with circumference we can do diameter times pi, but for area, there is no diameter included in here. It's got to be, you got to find the radius and then square it and then multiply that with pi.
yeah, students get that
Yes,
confused
they
for
do.
whatever reason. 2 times radius is completely different than radius squared.
Yeah.
So you got to be careful with that. Make sure you're squaring the radius, multiplying it by itself here for the area.
Yep. All right. So if we look at if we look at the area of a sector, like a piece of pie, it would be the measurement of the arc divided by 360 degrees times the area of the circle. And so remember, like Mr. Scritchell said, we're just trying to take a fraction of the circle and want to know the area of that fraction. So basically, that the measurement of arc AB over 360 is that fraction.
Right.
So it would be like if it was a 180-degree arc, that would be a 1/2 of a circle, and you just got to figure out the area of 1/2 of the circle.
Yeah.
So it's just the fraction of the circle times the area of the circle, and that gives you the area of that sector.
Right. That little diagram there looks like it's a fourth of the circle because it looks like it's a 90-degree angle.
Right.
90 over 360 is 1/4 of the circle. To find the area of that pie piece, it'd be a fourth of the full area. So it's pretty easy. You just
Yep.
need to get that concept down.
Yep. All right, so we're going to find the indicated measure here of these two pictures. So if we look at the first one, all we have to do to find the area of this valve would be to take the radius, which is 2.5 centimeters, square it, and multiply it to pi. And so we get that the area of the circle is 6.25 pi centimeters square, or approximately 19.63 centimeters squared. Just a thing to remember here, guys, is square the number before you multiply it with pi if you're trying to get the approximate answer, because you don't want to do 2.5 times pi and then square it, because you're really going to get a big inflated answer.
Yeah.
So, anyways, pretty basic stuff there.
Okay.
And then for this one, they give us the diameter. Now, for here, you got to be real careful. Remember, you cannot use diameter, or they want to know the diameter for this if the area of the circle is 113.1 centimeters squared. So you're going to have to work backwards here.
Right.
So you just set this up as 113.1 equals pi r squared, like that, okay? And then you're going to have to divide by pi and then square root, so it looks kind of like that. There's the division of pi and then the square root of the whole thing. And so then I just go 113.1 divided by, or the square root of, in parentheses, 113.1 divided by pi, and then close those parentheses, hit enter, and you'll get roughly 6 centimeters for the radius. Now be careful here. Make sure you read the question. It says at the top they want the diameter. So to go from radius to diameter, remember, it's double the radius, not the radius squared. You gotta know that subtle difference there. The diameter is just the radius times 2, and so my diameter is 12 centimeters, approximately.
Yep. Yeah.
Okay?
All right, so here we're finding the area of just part of the circle here, okay, called a sector. And so a sector is, again, a piece of pie or a piece of the circle. So if we want to find the area of that red or pink section there, we would find the area of the entire circle and then multiply it by what fraction of the circle we have. And so the fraction of the circle that we have is 120 degrees. That's the portion of the circle. So we put 120 over what the whole circle is, 360. So 120 over 360, the zeros will cancel. 12 over 36 gives you a 1/3. And so really what we have, the pink portion of this circle, is 1/3 of the entire circle. And so if we were to find the area of the entire circle, it would be the radius squared, 14 squared, times pi, and then 1/3 of that. So the area of the sector is 120 over 360, part of the circle, over 14 squared, or times 14 squared times pi. So if we work all that out, the 14 squared is 196 times pi, and then we would divide by the 3, that is essentially the denominator of that 120 over 360 of what it reduces to. So we end up with 196 pi over 3 as an exact answer, square feet, because we're in feet here. Or if you were to round it off and approximate it in your calculator, it would be about 205 1/4 square feet. All right? So again, it's just finding the area of the whole circle, multiply it by the fraction of the circle that you have. Okay. What about the area of the blue sector? Well, you could do that a couple different ways. You could either find the area of the whole circle and then subtract out the pink part, the red part that we just found. You could do that. Or if their pink part is 120 degrees, then that means that the blue part has to be 240 degrees. Or in other words, if the 120 over 360 was 1/3 of the circle, then the 240 over 360 is 2/3 of the circle. So you could do this a couple different ways, but we're going to do it the straightforward way with the formula. So 240 over 360 is 2/3 times the pi times the 14 squared. And so the 196 is going to get doubled because there's a 2 on top of that fraction now, and a 3 on the bottom still. So it's 392 pi over 3 square feet, or approximately double what we had before, 410.5. Okay? So we're just finding the areas of parts of circles here called sectors. Okay?
All right, so now we have kind of some composite shapes here that we want to find the area of, and so we're kind of combining all of these ideas. And now, hopefully most of you have recognized that this has a half circle in it, and so we're going to have to take half of the area of that. So, but they want us to find the area of the shaded region, so we want to find the area around that key. It looks like a basketball court to me.
Yeah.
And so, basically, our shape, guys, is a rectangle in the blue subtracted by a semicircle plus a square. Okay, so now all we got to do is find all those areas and then just kind of plug them in and follow the way it goes. So the area of the rectangle is a 36 by a 26. Notice that they have it broken into two pieces and they added those together to get 26. Minus, okay, the semicircle will be 4 pi pi r squared, and then cut that in half. So in this case, the diameter is 16, so cut that down to 4, okay, and then you square that. And then
Cut it down to 8.
Oh, cut down to 8,
the
I'm sorry.
radius.
For the radius, cut that 16 down to 8, excuse me, okay. Then, square that, multiply it by pi, and then divide that in half, and that's what they're going to show here. Or they do the area of a sector, 180 divided by 360 times pi r squared, plus the area of the square would be 16 times 16, since it's a square and one face of the square is 16, or one side of the square is 16, just square that for side squared. And you work through all that, and you get approximately 579 feet squared. I mean, guys, you could do 180 over 360 pi r or pi 8 squared, but I mean, if you know that a semicircle is half of it, remember, as Mr. Scritchfield and I said, it's a fraction of the circle, and if you know what that fraction is, in this case 1/2, you don't have to use those big old numbers of 180, 360 off the get-go. Just understand that 180 over 360 still reduces down to 1/2, and so it's the exact same thing. Okay, I mean, just
Lots of arithmetic there is all.
yeah,
Yep.
And then this one right here, we have a half circle and a isosceles right triangle, and so we need to find the area of that composite shape. So all we're going to do now is go area equals the semicircle plus the triangle. And so once again, we have 1/2 of a circle that we're looking at. So they're going to go 180 over 360 pi times 3.5 squared. Now the reason it's 3.5 squared, guys, is, and this is kind of something that you got to pay attention to, and I meant to say this before, but when that label for that semicircle, when that label is right next to the dot in the center, that means the diameter. If it's in one of the channels there, up or below, that means that's more the radius that you need to focus in on. So that's where the 3.5 comes in, is it's half of 7 plus, okay, since it's a right triangle, guys, the 7 is the base and the 7 is also the height here, and so you don't have to worry about drawing in an altitude or anything like that. So it's 1/2 of 7 times 7. Okay, do all the math, 1/2 pi 3.5 squared plus 1/2 of 49, and you get approximately 43.74 meters squared.
So we're still really just plugging into formulas
Yeah.
and just calculating things out. You just need to recognize what the formula is for part of a circle,
Yep.
and be able to do these composite shapes and see what shape you're actually looking for.
Yep.
So, okay, so we'll have more examples in class, guys.
All right,
See you there.
see you.